What's up, YouTube? It's Greg here from GregsTutoringNYC. What's going on? How's everybody out there doing? So I think it's been like 10 days since I did the part one to this. I'm trying to get my time back and so on. We're discussing hardest math problems on grade 8, part number 2. So I'm just going to pretty much jump in here today. I'm not exactly sure how much time I'm going to give to this. I'm going to at least do half an hour. Okay, we're live, so we're good. Please like and subscribe. And let me jump right in here. Let me get rid of this screen here. So we're doing problems that are sourced from the New York State tests. So we have a, it wants to know what the, wait, let me get the pen set up here. Make sure that's writing. Okay, we're good. Okay, which exponential expression is equal to this? So the problem we're going to have here is pretty much twofold. One is, what does each of these expressions mean by themselves? And then we have to go and actually solve each one of them. So this is kind of a time waster on top of kind of complexity. Most students are getting this question wrong. This is probably the most erroneous question out of all the questions I've done from grade 3, 4, 5, 6, 7, and 8 right now. This is probably the most erroneous one of all. So in some ways, this is the hardest question there is. So when we have an exponent situation, we have a base to an exponent. Okay. If we multiply, that is what that dot means, multiplication. So there's a whole bunch of ways to do multiplication. In fact, let me write down here. I can do stuff like A times B. Okay. Okay, I can replace, sometimes it's A, and they use an asterisk, which is the thing when you do a shift 8. So I can kind of write that in a weird way, kind of like a plus sign with an X through it. I can do A times B that way. Okay. Sometimes there's a dot notation, A dot B, like that. That's pretty much the way they're doing it up in the example right here, except it's kind of a larger dot. We can also do multiplication in other weird ways, like A times B with a parenthesis around the B. Okay. We can also swap that and put the B first, followed by the A. Okay, which is the same, this would be the equivalent if we want then, if that second form is allowed, and it is, to do that. And then obviously we can kind of combine the two ways and get, that should be a paren. Let me scribble that out. Paren A times paren B. Okay, that didn't come out looking right. Let me write that again over here. So all these are all the same forms of A times B. That's what everything here is saying. Okay, I probably even missed a form or two here. So this means 2 to the minus 5 times 2 to the 8. So we have a common base. So we have a base to some expression. I'm going to call it E1, which is the minus 5 times a base to some other exponent. I'm going to call that E2 for expression 2 or exponent number 2. What we do is we add the two exponents together. So this is the same as, I'm going to use like a tilde with an equal, meaning it's the identity. It's B to the E1 plus E2, taking together. Okay, if we want, we can put a parenthesis around that. So all we're going to end up doing is adding the minus 5 and the 8, and we get 3. Okay, so what we're looking for something is that is 2 to the third. Okay, 2 times 2 is 4, and 4 times 2 is 8. So we're looking for something that's either 8 straight up or 2 to the third. But it's saying which exponential expression. So if we look at all the choices, we notice they're all exponent gyrations. Okay, so what we have to do is figure out which one also is equal to 2 to the exponent of 3. Okay, so there's other rules where if I have a base to some exponent and a base divided by the same base to another exponent, I'm going to just call that f. This becomes the same as b to the e minus f. Okay, in our case, e is 2 and f is minus 1. So we get 2 to the 2 minus 1. Okay, and 2 minus 1 is 2 plus 1, or 3. So it turns out that A would be our answer, because that's also 2 to the 3. But let's just look at what some of the other ones have there. By the way, there's other ways to interpret this. We can use models to demonstrate how many of these things are going on. We could also go through what does it mean to have a negative exponent. So there's alternate ways to solve all these as well. So what we have here is when you have an exponent like b to the e with the parenthesis around it, and we raise that, we multiply those. So that means this times this is going to be multiplied. So this becomes 2 to the minus 3. Not 2 to the 3, but 2 to the minus 3. So that's no good. Okay? C looks similar to A, but we use the same rule we just did over here with the e minus f. So we're going to get minus 2 minus 1 as the exponent. And that's 2 plus 1, or minus 1. So that doesn't work either. So B and C are out. We're just double checking that we did A properly. And like I said with B, we're going to multiply the two of these. So B and D are actually both 2 to the minus 3. Because when we have B to the E to the F, we just do that multiplication there. So that doesn't help us, all right? And just to be clear, what's kind of going on here, we would have 2 to the minus 1, just to kind of do a shorthand here. This is 2 to the minus, I'm looking at D only. D is the wrong answer as well, but I'm just kind of expounding a little bit. This is 2 to the minus 1 times 2 to the minus 1. Times 2 to the minus 1 again. So that's 2 to the minus 1 3 times. So you can see it's 2 to the minus 3, right? Which has its own meaning. Okay, I'm not going to investigate. I'll make a statement right here, but just to kind of discuss it. If, for argument's sake, again, this kind of has nothing really directly to do with the problem. 2 to the minus 1 is the same as 1 over 2 to the same exponent. So these are a bunch of rules you need to know. We had the actual one here with b to the e1 times b to the e2. Those you add, the others you multiply, the others subtract. When we have a negative exponent, it means 1 over the same base and exponent, but without the negative. Okay? And 2 to the 1 is the same as 2, so this would just be equal to a half. So I'm only mentioning this because there's a whole bunch of exponent rules you guys need to know at this point. In this case, it was for taking the New York State test, but for you guys taking the SHSAT, the ISEE, the SSAT, the PSAT, the Bergen County Academy test, the Hunter College High School test, the TACHS, all these exams, the HSPT, they all require you to know this. And as you getting through grade 7 and grade 8, you should be knowing all this as well too. All right. Hey, I see a few people in the lobby there. Hello. You can peek in. If anybody has any questions about any other aspects of exponent manipulation, holler out. If you want to stay quiet, that's cool too. I'd love for this being interactive as possible. And you guys catching on the replay, you guys please like and subscribe as well. Set your notifications, and let's have a great time with some of this stuff. This is not good. My voice is going out already. So that's 27. Let's see what else we've got going on here. This is another one a lot of kids get wrong. Again, in this, by the way, just to give 10 more seconds on the previous question, there is other ways to solve the previous question. I want to be able to solve a variety of these. If anybody would like me to ever come back to that same problem, we can explore the other ways to do that by actually using that minus exponent in different ways, just to show you how the math turns out to work out. And all these identities involving the exponents are actually pretty cute and cool or whatever. All right, so let's see, that's on your screen, good. So I like to look at the illustration, so to speak, first. So I'm considering this two sets of equations, the illustration. So I have 5x plus 3x equals minus 6, 2x plus y equals minus 4. They both are forms of line of, many of you know y equals mx plus b. Okay, that may not necessarily help in solving this question, but it's good to know that you're observing that this is dealing with the forms of the equation of a linear equation, because there's an x and a y, and if we set y equal to, we can figure out what the m is, and so on, and the y-intercept and so on. So it looks to me so far that this has nothing to do with. This is also called simultaneous equations. In fact, if we start now looking at the words, it says system of equations. That's really what we're talking about here. So normally there's certain ways you were taught to solve this, by either substitution or by subtracting or adding one of the equations to the other, canceling out either x or y, solving for x or y, whichever's left, and then plugging it back in. Now in this case, they actually give us the point here. Okay. They actually give us one of the solution sets where x is minus 6 and 8 is y is 8. So this is coordinate geometry relating back into 2. So this looks like it's an algebra question, but it's also got geometry kind of intertwined on top of it. So that's why it's hard to categorize some of these sometimes. Sometimes somebody might ask me, like, what category of problem does this lie into? Formally, it's algebra, but it's delving into geometry. And of course, you need to know all arithmetic to be able to get this done. So it gets wishy-washy at certain points, really, what's being tested. And then I mentioned it's also dealing with the equation of a line on top of it, which is also geometry. So we don't, depends how we look at this, what techniques and what branch of the maths that we want to end up using with this kind of thing, all right? All right, so we have the two equations. It says the system is shown below. Cool. We don't know what's going to go on with it, what we should do with it. Probably it wants us to solve the simultaneous equation, but then it says what statements about the ordered pair is true. So at that point, we kind of have choices. So let's take a peek at the thing. It is the only solution. What is? They're talking about the minus 6, 8 coordinate pair. It is not a solution to either equation. It is one of many solutions to the system. It is a solution to the first, but not the second. So D is saying if we plug in minus 6, 8, I'm going to call these A and B. Okay. So choice number D is saying is if we plug minus 6, 8 into the 5x plus 3y equals minus 6, that'll work, but it won't work for the second one. So there's kind of a lot being thrown at us here, and there's actually an enormous way to kind of solve this. I would personally just straight up try to solve it, but you can rule out stuff like if if minus 6, 8 doesn't work in either equation, then B is out. And if it only works at 1, then D is in. All right, so you could do that. We can do that. So let me get rid of some of this other clutter I have here. Give me 1 second. And we'll try to approach it that way, at least initially. And again, this is another thing, just like the exponent question. There's a lot of ways to solve this question. So we're just going to take this way and do some exploration as we normally do. Okay. Okay, I like to beat some of these things to death. So if it's minus 6, right? That's going to be 5 times minus 6. And then 3 times 8, right? And then this is going to be the same. We're going to solve it here. So it's going to be 2 times minus 6, right? And y here is 8. So let's just try to solve it under those contexts. So 5 times minus 6 is minus 30. I'm going to write it up here. I'm just basically going to write it over where it is. And 8 times 3 is 24, so that's plus 24. Oh, and actually, let me make sure this is on you guys' screen. It may have fallen off the top. Nope, it seems to be there. And the question is, I'm going to put like a double question mark here. Is that equal to minus 6? Well, minus 30 plus 24 is minus 6. So minus 6 works for the first equation, and 8 works for the y. So we're good. So minus 6 comma 8 works for both of those. And if we come through on the second one, we have minus 12. Okay, plus 8, right? Because y is 8. And is that minus 4? Yes. So it works out on both. So so B is wrong because it's a solution to both, and D is wrong because it's a solution to both. So then C says, A says it's the only solution possible for X and Y, and C said is one of many solutions to the system. Since to me this is linear, both of these are linear equations, and we're solving one inside of the other. It's not going to be C. Okay, it's going to be A. All right. Another way to solve this was to do simultaneous equations, which is to get rid of one of the sets of lines here or the other. So I'm going to try to line up the y's so that there's 3y in both equations. Okay, the way I can do this is I'm going to multiply the whole second equation by 3, right? So if I do that, I'm going to get 6x plus 3y equals minus 12. Does everybody see that? I'm going to take every term of the left-hand side and every term of the right-hand side and multiply every term by the 3. All right? And then I'm just going to write underneath that the second equation. The first equation. Okay, and the reason I did this multiplication to get this is that I'm literally going to subtract the two equations from each other. So I'm going to take each term kind of one at a time. So I'm going to kind of break this down like that and then like that. Okay, and I'm going to kind of do it by rows there then. So what I'm going to get then is 6x minus 5x is just x. Okay, and then 3y, so I'm going to subtract the two of them, right? So 3y minus 3y gives us 0y. So there's nothing here. Okay, and then minus 12 minus minus 6 gives minus 6. Okay, and that means, because the equal drops down, x is minus 6. Okay, That's what they originally started us out with here. Okay, so now that, again, we can do this another way and solve a y the same way. Or we can just substitute the -6 into both equations and solve for y. And in both cases, we're going to get that 8 again. There's no alternative here. All right. So we were able to double check it that that's the case. In fact, the first solution I gave you was actually substituting the -6 and 8. So we know if it's -6 that the 8 works. So just to be clear on what I'm talking about is, so far we only have x equals -6. So if we actually plug that in, if we take, for instance, the first equation as one of the examples, we have 5x plus 3y equals -6. Let me fix that 3 better. The software, it doesn't like 7s or 3s or parentheses. I don't know why. So we're deciding that the -6 is here. So we're going to get 5 times -6, we're going to get -30. Plus 3y. Right? Because we're going to see if the y ends up being 8 then. Equals -6. So we're going to try to get y by itself. So we're going to add 30 to both sides. Right? So this -6 plus 30 ends up being 24. And then to get y by itself, we're going to divide both sides by 3. So 24 divided by 3 is 8. And that gives us back the 8 that was right here. Okay, and we can do that same thing with the second equation. I'll just narrate it instead of writing. We're going to have 2 times -6, so -12 plus y equals -4. Okay, and if I add 12 to both sides, I'm going to get y equals 8 straight up. Okay, so that's pretty much what's going on there. All right, so the answer to this question was A, and again, there's even more we can even say about this, but at this point, I'm going to go to the next question. Okay, so this ties back into the equation of a line once more. So this is a significant kind of thing going on here. So it says, which is the equation of the line that passes through 412, okay, and has a y-intercept of -2. So first of all, you have to know that if the equation of a line, and it's using this form, there's a couple forms, equals mx plus b, that m is the slope, and y is the y-intercept is b. Okay, so the y-intercept is b right here. Okay, so first of all, even though this right here is a plus sign, we can have an equation that looks like a, b, c, or d with that -2. Okay, so it turns out that each one of these equations has the -2 in it. So in terms of that requirement, right, there's 2 requirements. It has to pass through here, which is requirement A, and it has to have this other requirement B. So all the answer choices have requirement B. So what we need to do is see which one fits within the 4, 12 thing. Okay? So what we can do is actually just plug those in. The 4 here, that's the X, right? Whoops. And the 12 is going to be the Y. Okay? So we're just going to do that. We're going to do 12 equals, we don't know the slope, so that's what we need to figure out here. If we can determine the slope, we can figure out which one it is. So m, we know x is 4, So this is times 4. It's m times 4, right? So this is the same as 4m. We could look at it that way if we want to. And the y-intercept they told us was minus 2. Right? So again, as I just said, this is the same as 12 equals, just to kind of put it in a more standard form, m times 4 is the same as 4m. Minus 2. Okay? We need to get m by itself. So we're going to get rid of the 2. We're going to add 2 to both sides. And then we're going to get 14 equals the 4m. We're going to try to get the m by itself, so we're going to divide both sides by 4. This cancels out. So we get m equals 14 over 4, and if we reduce that, we can divide both sides by 2, we get 7 halves. So that turns out, that means m is our slope, right? So that's what we're looking for. So that turns out to be b. 7 halves is m. Y equals mx plus b. Y-intercept was minus 2. Booyah, we live happily ever after. Okay? There's no other way to do this except for doing it this way. There's really not an alternative here. We could have took the y-intercept because we don't know where to go with this. So technically, if we were to draw this, let me just do a quick mock-up of it, like right here. So they're telling us that the equation, the line passes through 4. So let's say this is in groups of 4, 8, 12, 4, 8. Let's make this slightly longer. 12. So it's telling us it's going to pass through 4, 12, which might be up here. Okay, and then it says there's a y-intercept of minus 2. So that means if this is minus 4, then it's going to pass through right there. So the line seems like it's going to be something like that. That does not go through the origin, even though it looks like I just drew it that it was. All right. So that's our equation there. So there's not too much that can help us here because the other thing is all the slopes are positive. So we can't even look and say there were negative slopes, right? And that the line went the other way. If the slope was negative, then the line would have gone like that, you know, that way of some sort. So none of those were those choices either. So there really was nothing else here that we can grasp on to really obtain this answer properly. All right. So that's to deal with that one as well. Okay, so we have another one here, which is going to also deal with coordinate geometry. So again, for those of you who followed this through grade 6 and grade 7, the ones I did for that, there's kind of a little quantum leap going on here, where the problems are now into like a totally different other kind of domain of solution sets. It's really out there, and that's why it's important to know all your prerequisite and requisite math, because this can get complicated real quick, and chaotic and confusing in a whole bunch of other things like that. All right. Let me just make sure we're live. Solution sets. It's really out there, and that's why it's important to know. Okay, again, if anybody has any questions about these, please ask. Again, I see a few guys in the lobby. Just got another like out there. P show, thank you. What was I just gonna say? Yeah. So if anybody has any questions, please ask. These are within the auspices of the hardest problems. So that's the deal. So I'm going to ignore the question for now. I see a line. It appears to be a line. It's running through a few quadrants, right? This is quadrant 1, 2, and then 3, and the last one is 4. You know, we can start figuring out stuff like we did just a minute ago. It appears like it's going through -3 right here. So that seems to be the y-intercept. I don't know if this is drawn to scale or not, so I don't know. You know, you could say that's 3.2 or 1.75, but for now we're just kind of just trying to get our bearings on this problem to see if that's really what's going on here. We notice it also seems to cross here at 5. Okay, that seems to be a reasonable thing. You know, is it 4.99? I'm not really sure. And it has a positive slope. In fact, we could try to figure it out. I don't know if the solution is going to demand that, right? So, but if we were to start trying to synthesize what the equation of this line might be, and we don't know that we need to do that, but if we do the y equals mx plus b kind of thing again, okay, just to kind of get bearings again, it looks like the y-intercept is 0, comma, -3. So it looks like that would be -3. Okay, just this kind of a best guess. And what we can do is try to match up where it appears that the line, if there's an intersection between where it meets right at a dot where the two hatches meet each other. So it seems to me it's unclear because the line as it's drawn seems to just miss a few of them. But what I'm trying to seek is that if we try to figure out the rise and versus the run, we might be able to get some conclusion. In other words, if we go from 0, 8, 8, 8, 2 to maybe where this is hitting there. It seems our rise is 3, and our run is 1, 2, 3, 4, 5. So that's probably what the equation of this line is. Y equals -3/5 x minus 3. I don't know. I'm just giving you guys insight as you try to solve other problems. I don't know that we need to do this to solve this problem yet because I'm only looking at the illustration and I'm only trying to grok it. So on test day, there are some problems I actually start solving. This one I would hold off on that to understand what it is because they may actually tell us the equation of this line. I don't know. Okay. So there's really not anything else going on in this thing. So we're going to kind of, you know, whether I had to just do this or not was another story. But at least I understand enough about it that I can get to that point if I needed to, if I actually need to do that to solve the problem, right? So let's go to the words now. Figure 1, that's this whole figure, is defined by the equation function 1, right? Not figure 1, function 1 is defined by this equation y equals -3/4 x plus 1. And function 2, so this is function 2. Okay, function 1 is not drawn then. So I don't know, the questions are not on the screen yet, so I don't know if it's going to ask us that. So here's what I'm going to do. I'm going to write function 1 down here so that we can scroll up and start looking at the choices. So y equals 3/4 x. And your test, you won't need to do this because you'll be able to see the page altogether. Plus 1. So what I'm thinking, without seeing the answers here, what I may need to do is actually graph this f1 function. Okay. Sometimes if the question is to say about the slope, for instance, we know the slope of the line drawn there is positive, and we know the slope of f1 is also positive. So if the question is like, do they both have positive slopes, then you're done with the question. It's over with. We don't know what they're going to ask for. So let me go back to the questions again and just make sure I'm seeing what's kind of there. So function 1 is defined by the equation y equals 3/4 x plus 1, and function 2 is represented by the graph below. All right, so let me scroll that up to a point where I kind of can see all the answer choices and the graph all at the same time. Let me see if that's fitting on your guys' screen. Yes, I think it is. Okay. So it says, which of the statements is true about the function? Give me 1 second to line this up better still, because it cut off for a second. Wait a second. Yeah. Okay. Wait. Nope. Yeah. Okay. All right. The y-intercept at the very last line is pseudo cut off, but I think you guys can see that. Should I move it up a little more? We're okay. I'm going to waste time trying to move this back and forth. So which statement about the functions is true? Function 1 has a greater range of change and a greater y-intercept. Function 2, so they're going to start comparing this A versus B thing. So they're talking about rates of change and then comparisons of y-intercepts. So which one has the greater y-intercept? Well, the B here is -3. Let me change the color of this. So the y-intercept here is -3, and the y-intercept here is 1. Okay? So it seems to me that this is true, B is true here. Okay? So function 2 has the greater, so we're just going to look at the y-intercept at this point. So B is wrong because function 2 has a smaller y-intercept. Function C, let's see, function 1 has the greater rate of change, function 2 has the greater y-intercept. I put F2 there, that should have been F1. Sorry for the confusion. Function 1 has the greater rate of change and the greater y-intercept. Function 1 has the greater rate of change, and function 2 has the greater y-intercept. So function 2 is the one I computed for. No, that's false. And function 2 has a greater rate of change, and function 1 has a greater y-intercept. All right, so we're left with A versus D. So which one has a greater range of change? In other words, if we compare 3/4 versus 3/5, that's really what they're asking us here. Okay, and we can actually go and quickly do that. We can also do the cross product and figure out that 15 is greater than 12. So it's going to be steeper. But let's actually go through that. So for that, it's telling us the y-intercept here is 1. So that's going to bring us about right there, right? And then it's telling us that the rise over the run is that. So if I go over 4, that's going to bring us here, and up 3. That's going to bring us here, right? I can kind of do it a couple times to get a few points. Over 4, up 3, right? Over 4, up 3, and I can even go down the other way. But if you notice, it's subtle. Let me try to draw this as best I can. It's subtle, but you can see that's slightly steeper, right? So this is F1 again. It's just slightly steeper. Okay, and by the way, when we did the crossbar, I've got 15 versus 12. They're kind of close enough to each other as well. All right, so you see how I did that? There's a couple of ways to do it. They both have a positive slope, so there's nothing there. So basically, if function 1 is the greater rate of change, that means in terms of the A part of the question, that choice number A wins. And choice number D, it says function 2 has a rate of greater change, but 3/5 rate of change is not greater than 3/4. So D is out. Okay, so that's what it's asking here. This is a pretty busy question. So you can see why kids can get it wrong. And we could have picked up. We didn't. So again, we didn't really need to go and do this. What I did here, but we have to note that even if it's not exactly -3, right? We don't know if this 3/5 x minus 3 is actually the equation. But we know that because it told us this was plus 1, that plus 1 is clearly greater than minus 3, right? So from that, we know A and D were the only options, and B and C was out, okay? And again, if we do the two rates, even if we're off by a little, it's clear that the two slopes were not, they're not parallel lines at all, right? If we plot a whole bunch of points, we can see that. We can see that the slope, because if we mimic the line that was pretty close to the one that was there, in other words, to make it parallel, let's see, 1, 2.5, 1, 2.5. It would be there like that. That would be the line. The purple line would be parallel to the pre-printed line there. So you can see this little gap here. As we go down, this widens a little. Okay? So it's subtle, but it's there. Okay, and that's probably why they created the question. And it might turn out to be why some kids got it wrong. I just think this was a plain old basic problem using, again, a whole bunch of different parts of math. A lot of kids just melt down when you need to plug in values and compute slopes and do all these kind of comparison kind of things. But that's the deal with that there. All right, so how we doing on time here? Give me 1 second. Let's see. We've gone about 45 minutes, so maybe we'll do, well, let's see how long this problem takes, maybe 2 or 3 more. So there's only words here. A cylinder has a diameter of 14 centimeters and a volume of 112 pi cubic centimeters. What is the height in centimeters of the cylinder? Okay, so I'm hoping somehow that this pi gets canceled out. Okay, so we need the height. So it says that the volume of a cylinder, you guys should know. So if you don't, there's a way to kind of think about it to kind of get you there. So if you consider what a cylinder is, we basically have a circle. Okay, a circle might have a radius. Okay, so you should know that the circumference of a circle. Okay, these are formulas you guys should know no matter which test you're taking here. So this is the circumference would be 2 pi r. You should also know that the radius is two radiuses make a diameter. So in other words, if I extended this across, the green plus the purple would be the diameter. So that would be 2 radiuses. So we can also say this is pi d. Okay, the area of a circle, I'm just going to put a little circle there, is equal to pi r squared. So again, you guys need to know this. If you don't know it, you're not doing well. The good news is there's only at most a dozen formulas you have to know. Okay, so what's just interesting about the cylinder is if you memorize what the circle is, then we actually complete now drawing the cylinder. And that would be the bottom. Okay, there's a way to think about this, which is there's a whole bunch of circles stacked up on top of each other to a height of h. Okay, so a way to look at this is the volume of a cylinder. Whoops, I don't know why I wrote the letter y. The volume of the cylinder is going to be that circle, so pi r squared, times h. Okay. Like and subscribe. Bargain Weasel. Okay, so pi r squared. So all we have to do is they already told us this was 112. So we know that's going to be equal to 112 pi. Um, Welcome anybody else in the lobby. Feel free to talk as well. Um, and if you have questions that are not pertaining to what I'm talking about, I will cover them at the end. Um, and as I said, we might do 2 or 3 more problems, maybe just one at this point. Let's see. So we know it had a diameter of 14 centimeters. So therefore, r is equal to 7 then. Okay. So that means we know we're going to have pi times 7 squared, so that's 49, times h. And that's going to be equal to 112 pi. So our goal is going to try to get h by itself. So if we get rid of the pi, we're going to divide both sides by pi, so we're going to get rid of that, and we still need to get rid of get h by itself, so we're going to divide both sides by 49. So that's what we're going to end up getting. We're going to get 112 over 49. Okay, so we need to try to figure out how to reduce that, because that's not one of the answers. So either we solve this wrong, or we need to simplify the fraction. So all of you should know that there's really not much going on with 49, except for 7 times 7, okay, and 1 times 49. So the 1 times 49 is not really going to help us. So we have to go about a 7 by 7. So the question is 112 divisible by 7? Okay, many of you probably don't know that just by looking at it. I don't. So let's try it. 7 goes into 1, it doesn't. 7 goes to 11 one time with 4 left over. 7 goes into 42 6 times. So we end up reducing this to 16 over 7. And that turns out to be choice number C. Right? So a lot of this really comes down to, knowing the diameter is twice the radius and memorizing the formulas. If you don't memorize this straight up, you can kind of use this little trick or just logical solution to be able to get that from there. Okay, there's other ways to memorize just based on the area of a circle to get some of the other formulas. I do have that in a video a couple of years ago. I think it's called geometry something, maybe about 2 years ago. Um, I can put a link in the comments myself later on to find out where that link is. In fact, I might be able to find it real quick right now. Let me just see. Give me 2 seconds. If I can't solve this in 2 seconds, I'll post it later. Meantime, I'm Greg from Greg's Tutoring NYC. Please like, please subscribe, please enjoy the videos, please share them, please write comments. Okay, we're trying to have a nice fun time here, learning stuff that a lot of kids are getting wrong. And this is not only nice and useful in its own right, but you guys can use this for all these other exams that you're taking, not just the New York State test. So again, it's not even so much that you know the material. These are examples that kids are getting wrong. And the question is, why are they getting wrong? Okay. So these are examples that even when you know enough of the material, that they're error prone on top of that. So some are complicated in their own right mathematically, but some start falling into the category of the so-called silly errors. And I've found that the majority of silly errors that kids make are actually not silly errors. They're about lack of proficiency. I kind of thought I knew the formula. I kind of thought I knew how to solve this. Those kind of things like that. That's really pressing that, you know what, you really don't know how to solve this. Okay? That's the kind of thing that's going on there. So you guys need to kind of bump up your game on those kind of things. And just sometimes you have to do just sit down and sweat through certain things. As much as math is not about memorizing and all this kind of stuff like that, there's enough scenarios where that's part of what you need to do. So for this kind of a question, unfortunately, you need to memorize the formulas. There's really no way around it, or you at least have to have some way to try to figure that out. Okay, give me one more second, because I'm about 2 seconds to finding the video I'm talking about. Where is it? Okay, I believe it's this one. I'm going to post it in the links. I'm going to post it in the chat, sorry. Okay, I believe this is the video I'm talking about, which shows you basically the area and volume formulas you need to know for your grade level, and then you guys will just work on that, and it's kind of a way to memorize it. So work with that, see where it goes, and I'll check after I do this video if that's really was the video that I'm thinking of. All right, so that's 46. Let's try to do one more. All right, so this problem I think is less hard than that people are not reading the question correctly. So, and again, this ties back into the attention to detail kind of a thing where, you know, you need to have your A game on and your mastery sitting there in front of you. So let's just kind of beat this up a little bit. So the winning time for a men's 400-meter race in the Olympic Games from 1976 to 1996. So there's 20 years involved there. Is that right? Yeah, 20 years. Can be modeled by this equation here, where X is the number of years after 1976. And Y is the winning time in seconds. So if the relationship continues, which relationship? They're talking about that Y equals minus 0.54x plus 44.54. So and again, if you notice what I was talking about in the last 2 or 3 examples, this is also the equation of a line. And that's why it becomes important, because what it's trying to do is model something happened at a certain point that they found out. I'm just going to draw a random line here. That at some point, that's how the timing of the winners went. So that the improvement was tiny, but there was a slight improvement. And they found that from 1976 onward, it was constant, is basically. Okay? So which equation could be used to predict the winning time in the year 2020? Okay? So there's, I think, a few points of confusion here. So it says X is the number of years after 1976. So for that reason, A can't be the choice. And then even though it mentions 2020 here, X is not 2020 either. It's a number of years. All right. And then I think kind of what happens is that some kids are not reading the question right. So basically what you can do is 2020 minus 1996. So if you do that, you're going to get to 24 out of it. Okay. So I think enough kids are saying, okay, this is the equation that can be modeled from 76 to 96. So afterwards is what's going to happen. And that's why they're getting the 24 from afterwards. However, it's saying it's talking about from 1976. So that's 44 years. Whereas 2020 minus 1976, that's 44 years. So I have a feeling enough kids ruled out A and B, but some of you kind of misread the question, thinking, oh, the model is from 1996 onward. But it's telling you the model started in 1976. The model, depending on if the x-axis was the years, whatever's going on between those 2 points from here to here. We don't know where it went, but it's telling us from here to here, there's a line, and it's telling us it continued afterwards. So let me change the color of that. So the red part here, it's telling us that this is 1976. So I'm just going to write 76 here. And this is 96. So while it's true the line stayed as a line after 96, the equation is being based from 76. Okay, so that's the issue there. And if you reread the question, right, that's exactly what it's saying to you. It says X is the number of years after 1976, not after 1996. All right. Let me just take a quick peek at the next question. It's easy enough, I'll do it. If it's not easy enough, we won't. And this is going to be the last question, I guess. Okay, Kevin moved from a city to a small town. Awesome. He's an awesome dude. The population of the city is 6 times 10 to the minus 10 to the 5, which is approximately 15 times as great as the small town, which would represent the population of the small town. So what we're trying to look for is 6 times 10 to the 15th. Sorry, 6 times 10 to the 5. Divided by 15. Because if the population of the city is 15 times larger, then that means the population of the town is 15 times smaller. So when you solve these kind of problems with exponents or so-called scientific notation, because this first thing is in the form of scientific notation, at least informally, technically there should be a dot there to make it scientific and a dot zero. So we can put that in there. What we want to do normally is break it down into 2 parts. So basically we have 6 times 10 to the 5. And this is not a requirement, but it certainly makes it easier. What we're going to do is kind of split it in half, even though we're still going to use that. We're going to put the 15 under here. Right? So this is if it's 15 times 10 to the 1. 10 to the 1 is, 10 to the 0. So that's just 1, so it's 15. So basically what we're going to have is 6 over 15, because this is times 1 then, right? So we can actually split these off into 2 fractions. We can get 6 over 15. Whoops. Times 10 to the 5. Okay, that's the mathematical equivalent of what we do to get that. By the way, these are kind of pattern questions, this type of question, because they're trying to get us to shoot for anything in here. So what we basically have to do is, none of these are fractions on the left. There's 4 and 9 versus 10 to the something on each side. So what we have to do is map the fraction first, and then map it into some alternate scientific notation, basically. Again, this is informal because there's no dot zero in any of these, but that's where we're going. So basically our question is, what do we do with the 6/15? Well, we can divide 15 into 6. Okay, 15 goes into 6, it doesn't do it. We can bring up the decimal point. 15 goes into 60 4 times. So that's it, we're done. It's 0.4. It's 4/10. So what we have is 0.4 times 10 to the 5. Okay, the problem we have is if we solve this correctly, that would tend to rule out C and D, and we're stuck between choosing between A and B. So what we need to do is get this 0.4 to be 4. So let's take a quick sidebar. So we want to, this is where the numeracy and fluidity and no hesitation math and your mastery comes into sense. That if I have A times B, okay, and it's equal to C. Okay, go in the sidebar here. This is indirectly related to the question here. If I multiply A by 10, if I do say 10A here, in order to get, let me erase that for a second. That came out sloppy. If I multiply A by 10, then in order to still get equal C, I have to divide B by 10. So think of this as a seesaw in a way. And if this was actually the equation, 10A times B over 10, we can see that there's two 10s cancel out, and it brings us back to the A times B equals C. Okay? So what I did was I multiplied, I did no other operation. I'm not adding, I'm talking about multiplication. So I basically jacked up the magnitude of A by 10. Therefore, I had to jack down the magnitude of B by 10. So I jack up A by multiplication, and I jack down B by division. Okay? So we need to come over here and do that same thing. So if we multiply 0.4 by 10, right? So that's purple. We're going to multiply this by 10. Okay, and 0.4 by 10 gives us 4. So now we're cool. So what we need to do is take the 10 to the 5th and divide that by 10. And if you know your exponent situations, this is times 10. So we're removing a 10, basically. We're dividing by a 10, right? We get 10 to the 4th. Okay, and that gives us B. All right? Okay, there's other ways to look at this too, where I could say if I move this decimal point over by 1, let me change the, if I move this decimal point over to here, then I have to basically take the decimal point here and move it over, right? So if I'm taking something like 10, with 5 zeros, right, after it. So if I'm moving this decimal point this way, I have to move the decimal point here that way. So this is the same as 100,000. If I move this decimal point over here, I'm basically getting rid of that 0. So this 10 to the 5th now becomes 10 to the 4th. All right, does that make sense? Okay, that's what's going on. This is a classic standardized test question. It's a classic scenario in your classrooms dealing with exponents, dealing with scientific notation, and so on. And by the way, again, it would, so formally in scientific notation, it would be 4.0 times 10 to the 4th. So because there's no 0.0 there, this is not formally scientific notation, but that's the realm you're into. And when you get into physics classes and chemistry classes, you may need to be needing some of this as well. Let me see if there's something at the bottom of this page. No, there's not. What's the next question? Let me just see if I can squeak that in super quick. Yeah, you know what? We're going to do that. So which of the equations below are linear equations? So again, this keeps coming up, y equals mx plus b. So I was asking which of these, equation 1, 2, or 3, matches this form. Now, some of you might say none of them. Well, that's not one of the answers. So it has to be at least one of them then. So the question is, which one or more of them follows this? Well, there's something called first order equations. So this is basically if I have 5x, right? This means 5x to the 1. There's only 1x. So this is a first order term. So this is also a first order equation, the y equals mx plus b. All right? So in a linear equation, there's no exponentiation greater than 1 occurring. Okay? So what am I talking about? This 3 right here is greater than 1, and this 2 right here is also greater than 1. So for that reason, 2 and 3 are out. Okay? So then it says, which are linear? So that rules out D, that rules out C, and that rules out B. So the only linear equation is 1. So that gives us choice number A. All right? You might still argue, I don't get it. Well, if I set this up like this, y equals, you might get that these 2 and 3 ruled out, but you may not be understanding why c equals 2 pi r satisfies this. Because we can get this, 2 pi r So in this case, the r is the x, right? It doesn't have to be called x. These are symbols. When I say y equals mx plus b, I could write z equals a f plus c. So these are just standard conventions that we call this y and x and b. They're only standard conventions. They're representing something, they're modeling the real world, and they're just common terms we give. So now your question is, well, if r can represent what x talks about, where is b? Well, b is 0. B is 0. So that means the y-intercept is just 0. Whatever happens with this line, and 2 pi is a constant, right? If pi was 5, you would know the answer would be 10. So a lot of you know, say pi is like 3.14, etc., etc., right? So 2 pi is basically 6.28. So this is something 6.28 something r. That's all this ends up being. We can change that to be 6.28. Okay. When the b is 0, we just don't even include it. But it's there. It's implicitly there. So for that reason, the first equation actually models this y equals mx plus b notation. All right? And we can model this because if r is 1, right? Let's try to actually try to maybe graph some of it. If r is 1, let's just do I have enough room to do that? No, let me erase this for 1 second. We can kind of visualize it better. And I'm just going to do a few points of it. So let's say that's 10. That's 5. Half of it's 5. And we'll go what? 4, 3, 2, 1. So if that's 5, that's going to be 5. And that's going to be 10. Let me just label that so you're getting a context of it. Okay, so this x-axis is actually r. Okay, and the y-axis is still y, because we said y equals whatever. And by the way, it's c. So let's just call it what they're giving it. So this is C, the C axis, and this is R. And then it's C equals 2 pi R, because that's what it's telling us. All right? So if R is 1, right, then C is 6.28. So it's about right here. Okay? So we know that the Y, when R is 0, C is also 0. So we're gonna get that in as well. And we know that we can double check it because we already know the y-intercept was 0. Okay, so we have that. So we have something that's super steep. So when R is 2, right, we're going to get like 12. So it's going to be up here. And that's going to be our line. It's going to be like this. Oops, I'm drawing sloppy, but okay, I didn't actually go through the dots I drew, but you guys get the idea. All right, so we're going to have this, we're going to have the super steep line. Here, let me just erase that for 1 second. Redo it. Let's see how I can do this best. Okay, that's what it is. So since we can do that, we're physically proving now that this is illustrative of being an equation of a line, because we can map it and actually draw it out. Okay, so that's really what's going on there. So if you notice, just to kind of wrap up, a lot of things turned out to be a line. A lot of these examples were lines, which is where a lot of kids were getting them wrong. But even cell phone plans where you're paying $50 monthly and then you're paying per megabyte or some other feature that you're adding on, that's also the equation of a line, where your base fee, your y-intercept is going to be the $50, and then per month or per week or per day or per gigabyte, there's a certain rate, right? So you might pay $1 per week extra on top of your base fee. You might pay a dollar per gig or something on top of that, or whatever too. We should be so lucky it's only $1, right? All right. So with that in mind, everybody, hopefully enjoy your day. Again, please smash the like button. This takes a lot of time and energy to do, guys. There's going to be about 4 or 5, 6 parts of this. I don't know exactly how many yet. There's maybe about 100 problems to go through, and now we've gone through maybe 20, I think. So there's at least be 3 or 4 more sections. Y'all have a great day, and peace out.